So we're the ROVrunners. We're based out of Linn-Benton Community College in Albany, Oregon. This is Hunter.
Oh, you can, if you introduce everybody, we'll never get there.
Oh, okay, that's it. All right.
Not that I don't want to know
No.
each and every one of you, but we'll find it out during
Awesome.
the presentation. So how many years in the competition?
I think this is our 16th year.
Wow, it's about as many as I've been judging. So I generally judge pool. You may have had me for a pool judge at some point, but I don't remember you. Are you ready?
5-minute warning and 1-minute warning. He's gonna get one.
Unless I forget.
Okay. So.
Are you ready?
Okay, one question. So is everyone going to introduce themselves when we get up there, or are we just going to start the presentation?
You're gonna start the presentation and do whatever you want for 15 minutes.
Awesome.
Include your introduction.
Yes.
And that's the last thing you can say. Okay?
Thank you.
Go.
Hi, I'm Sierra Brightly. I'm the CEO of the Linn-Benton ROVrunners.
Our company prioritizes equipment, operation, and personnel safety in every mission and deployment of Spike. Our company chose direction of designing Spike with no sharp edges, corners, with minimal joints to decrease the need for fasteners. Spike is equipped with several built-in safety features. All propellers are enclosed with an in-house designed thruster shroud. This allows water to flow freely while preventing debris, marine life, or even human appendages from coming in contact with the rotating blades. The pneumatic systems was designed with materials with shape in mind to protect smart cables, valves, and will not harm marine animals or humans. The Spike tether includes lights to show that the current is no longer in the tether. There is strain relief, and we have a 30-amp fuse. This fuse was chosen in order to protect operation people in the water and marine life. Operational safety is enhanced by us having a pre-dive checklist to ensure that all systems are functioning correctly before deployment. We also verbalize commands such as robot on and robot off to prevent miscommunication, and this is to also clearly indicate when Spike is in operational status. Additionally, we have temperature sensors within the waterproof electric housing to provide real-time data monitoring, allowing for immediate corrective actions during deployment. While doing maintenance and construction on Spike, team members will always wear PPE. By integrating these safety measures, the ROVrunners ensure a secure and efficient environment for both our team and equipment, maintaining the highest standards of operational safety throughout all missions.
One other thing that's important to our company is teamwork. Twice a week we meet up for pool tests and a meeting up of the sub-teams. And when we're not doing that, we're using lab books, Discord, and Google platforms to communicate. We also like to mentor the incoming people because as a community college we only got 2 years. So we do some beginner courses on 3D printing and CAD design. Just because we teach those doesn't mean we know everything, so we had to redesign the frame and control system as well as employ a manager for this housing system because of flooding. Some technical issues we had were we no longer used heat cure epoxy, and you always know to back up your code. I'd like to thank a couple of our sponsors, the Oregon Space Grant Consortium, YMCA, MTS Oregon, Sexton, and the Mid-Valley STEM CTE Hub.
Our product is created to assist with the global conservation goals of our ocean and ecosystems, especially those afflicted by climate change. We contribute to conservation efforts with installation, expansion, and repair of underwater communication systems, allowing the collection of data such as conductivity, temperature, and depth. Specifically, we're going to be working with, we use our product's pneumatic systems to delicately transplant coral and install systems that promote growth in sensitive environments. In preservation efforts, we can observe the migration patterns of fish that are tagged with sonic tags, such as lake sturgeon, and using acoustic receivers, both placed and received by Spike, we can look at that.
Another major goal of ours is to have a completely self-made ROV. You can see that this year in our custom electric housing, cameras, thruster mounts, and manipulators. Our design is robust, made with PET-G, extruded aluminum, and plumbing parts that far exceed our necessary limits, ESI limits. Our design is completely modular, and it's made possible with our custom cables, which allows for the removal of every component. That includes thrusters, power converters, cables, and controls. So now I'm introducing Spike. Spike has several systems. Buoyancy, cameras, electrical, pneumatic are all in one, thruster and housing and frame, propulsion, and controls. Spike's buoyancy system features subsea polyurethane buoyancy foam on the bottom here, and foam pipe, which were chosen for their reliability, and the foam pipe's ability to also act as cable management. The vehicle's camera system was chosen for its low latency and minimal computing power. We have 3 analog cameras. Spike's electrical system has been totally revamped this year, featuring, we have our unique in-house electrical housing. We have our 15-meter tether, which connects to 3 48 to 12 volt converters. Those converters power our thrusters and our cameras. Inside of the housing are our 2 12 volt to 5 volt converters, which power our controls, such as the Raspberry Pi and Arduino.
The pneumatic system on the Spike, we chose to use surface-side solenoids instead of waterproofing solenoids because we found waterproofing solenoids could never be as reliable as the surface-side counterparts. So to reduce cost in replacing damages on solenoids and also the redundancy required for underwater solenoids, we decided to stick with surface-side and keep them out of the water. One of the 2 main purposes of the pneumatic system is to actuate the claw. The claw is built from PLA and resin, and it is a robust and reliable system. The thing that makes our claw unique is the spike that sticks out from the base. The spike is designed for its tip to be in line with where the slots on the end of the claw will line up with object-wise when it is fully closed. This allows for our pilots to more easily control and orient the claw for grabbing objects like coral or other sea-related things like rocks. The other purpose of the pneumatic system is to control what we call the GREG, the Great Rotary Excellent Grabber. The GREG uses a rack and pinion to convert the horizontal movements from the actuator into rotational movements so that it can turn the irrigation valve and turn the irrigation on for coral-based missions. And the GREG head is also designed to account for pilot error on approach. So even at extreme angles, or if the prongs are badly lined up with the handle, it can still reorient itself automatically to be able to latch onto the handle. On Spike, our frame is built from black extruded aluminum that is ready to use out of the box, and its corners have the motor housings already built in. These are designed and printed in-house using a new chemical and UV resistant PET-G filament that is also very durable. The housings are built to be extremely modular with slots on the inside for ease of replacement and installation of motors.
Spike is powered by 6 Blue Robotics T200 thrusters There are 4 cardinal motors mounted diagonally on each corner to prevent efficiency losses from partially blocking the thrusters with the frame. And there are 2 vertical thrusters that are mounted aligned with the claw and the greg to allow for careful positioning of Spike's manipulators. The control system that commands the thrusters is structured around a Raspberry Pi. Its exposed pins and variety of ports allow it to interface with a wide range of electronics and facilitate planned future extensions of the product. It connects with a surface-side PC, a status LED, a motor controller, and various sensors. For a motor controller, the company was considering 2 alternatives, a PCA 9685 board or an Arduino. The Arduino has a larger form factor and higher power requirements, but it's able to run custom firmware that can detect and recover from certain errors. Experiments also with various brands of PCA boards also showed that their motor outputs had errors of as much as 3%. And running the same experiment on the Arduinos resulted in motor errors of less than 0.5%. So taking these benchmarks into account, the company chose to use the Arduino. The Raspberry Pi also calculates the robot's orientation using a gyroscope and accelerometer, and it sends this data to the Surface PC, where a custom GUI application dynamically animates different views of the robot to allow the pilot to easily grasp its current orientation in the water. The PC reads inputs from an Xbox controller and uses an empirically tuned model of the robot's kinematics to calculate thruster signals, which it then sends to the Pi and to the Arduino.
So our company values
You have 4 minutes, so I get through.
Oh, okay. Our company values self-sufficiency with the goal of manufacturing all the parts in-house. And so this year we did a couple redesigns, one of which being the connectors here. And we did that, one, because it decreased price by a lot, and it also increased modularity, so future designs we can add more parts, take away parts, we're good to go. And then we also did a redesign on the frame this year. And that was between last year's model and this year's model, decreased the weight by about half. And then we also did a tether redesign, which is more flexible, allowing for better maneuverability. So whatever tasks Spike is tasked with, it's able to accomplish that better. And then between last year's model and this year's model, we reused the claw design, and that's because at the end of the day it works. And we also ran into resource management and time constraints. So it made sense to reduce, reuse, and recycle the claw from last year. And then we also purchased our thrusters this year. And that is because, again, resource allocation and time management. So we have plans in the future to build our own thrusters in-house to realign to our goal of being self-sufficient.
Outside of technical details, we look to the future with youth outreach programs. In the Linn County area, we engage in STEM activities geared towards understanding electricity and code with the hopes that we can inspire the future generations of robotic engineers.
We now open the floor for questions.
Okay, so you got 2 minutes and 40 seconds left. You want to use them for questions? That's fine with us.
Yeah.
Cool.
Yeah.
So I have a couple questions. Your use of pneumatics for actuators is unusual. Why would you not use just motors, stepper motors?
Reliability.
So you're worried about flooding?
In part, it's harder to waterproof motors and keep those motors working. Electric motors fail. Pneumatics have never failed us. The only part pneumatics that haven't failed us is the electric part.
If I understood correctly, you're taking the MATE supplied 48 volts and converting it to 12 volts at the surface. Why would you do that?
That's not quite correct.
Oh, yeah.
We have 3 48 volt to 12 volt converters on the bottom of the electrical house.
Oh, okay.
So yeah, the MATE supplies the 48 volt, and then we have the 48
You
volt.
convert it to surface. Okay, that's the right
Okay.
thing to do. So your transmission losses would be higher even on a short tether like this.
So, who are your sponsors and mentors for this?
I tend to say the list. I got Oregon Grand Space Consortium, the YMCA let us use their pool, MTS Oregon, Sexton, and the Mid-Valley STEM CDE Hub is our local makerspace, so they let us 3D print stuff.
Our mentors are Greg and Heather as well, so thank you.
So where did you source your underwater connectors?
Yeah, so the underwater connectors are actually originally designed by an open source project called the Cave Pearl Project. These are they're made out of low cost plumbing parts, so each connector, both sides is $6 to make the whole entire
So you
thing.
made your underwater connectors?
We made our underwater connectors, and we've
Yeah.
yes. So we've adapted them to work for our needs because they use thinner wire than we do. So this is actually probably the easiest to see.
Have any of them leaked?
No?
Yeah.
They're rated. The plumbing parts are rated for 100 psi, which is
Yeah.
much further than we make them now.
We don't take it apart, I don't know.
It's really cool. So I really want to show you.
So are these shelves 3D printed?
No, those are just plumbing parts you buy from Home Depot.
It's like a sprinkler system.
Right there.
So have you seen other teams use these?
No? I found them on some blog, and it's two doctorates. It's Cave Pearl Project, and what they do is they make Arduino loggers to gather data from underwater cave.
Sierra Leone, I think it's worked, so.
Oh, yeah.
Oh.
Yeah.
Shucks.
I believe you,
Okay, yeah, it's really cool. So they-
Seal in there.
Yeah, there's a rubber seal, and then the two terminals connect them.
Yeah, so we use male to female connectors, so we have on one side one male, one female, and then on the other side one male, one female, so we make sure we always make the right connection.
And we made sure to sand them all down because they were extra pokey.
Well, that's brilliant.
She looks a lot different.
No, totally
We
because
reuse design. We use
Yeah.
the epoxy all over electronics. This is our first time in several years using a waterproof housing.
yes,
It has been an adventure, but we're pretty proud of it.
In fact, I believe the claw piece is the only piece that was actually carried over from
Yes.
the
and
previous.
those are supposed to be pre-printed, but
Yeah.
same design.
So you said, when you mentioned the material, that it was UV protected?
Oh, we're using PETG, so it's UV and chemical resistant and more durable than the PLA we were previously
Who
using.
cares about UV?
It's a cool feature to advertise.
So what is your bottle made out of? Did you?
It's a clear PVC.
Okay.
We
So
had-
you guys cut your own
We cut it,
connector.
we
Correct.
cut holes
Yes.
and we
Yes.
epoxied the connector pieces into it. It's completely custom made, yeah.
So does it stay waterproof?
Yes.
Yeah.
Have you had any leaks?
Okay, the first time.
The very first
That was
edition
easier.
of the pressure housing
Yeah.
leaked the first time we used it, and we learned from those mistakes.
Yep, and the issue with that was just not
Really?
tightening these enough, and so
Yeah.
it didn't form a proper seal. After that, though, when we implemented the tube management, now we just before, is it tight? Is it watertight?
How do you make sure you don't over torque it though?
So we go hand tight and then turn 1/4, and it works every time. So
Okay.
That's pretty coarse thread. Yeah, I think this is a much better design than the people who go in through the cap, and then every time they take the cap off, they're dragging all sorts of wires in.
It is kind of difficult to connect the wires in this design,
Yeah.
but, trade-offs.
So is it ever overheated?
No.
So, is your circuitry mounted to a wooden mold?
Correct.
Yes.
Why not a heatsink?
There is a heatsink on the Raspberry Pi, which is by far the hottest component,
Yeah.
but we haven't had any other thermal issues. So there's also fans on the Raspberry Pi, which I forgot to mention.
So you're just circulating air inside?
Yeah.
But you have no metal heat sinks?
Yeah.
Or you do?
Just one of
Internal.
Internal.
Yeah,
Metal heat sinks to us
It's-
would be
yeah.
exposed to water.
we have.
We run it for extended periods of time.
If you don't need it, you don't need it.
Yeah.
We probably would, and we haven't.
The best technique, whenever you can do, is empirical.
Yeah.
A lot of people spend a lot of time solving problems that they don't know they weren't gonna have.
When you said you were stepping down your voltage, you're doing it in a box
We have.
outside, or is it just on the bottom
It's
of
the,
those?
we have the 348 to 12 volt converters at the
Okay.
bottom here. They're just like golf cart converters that we've epoxied so that they're extra waterproof. And then these two boxes are two 12 to 5 volt converters.
So that's probably why I don't get that happen there.
Yes.
So what's your testing regimen then?
Testing regimen, so
We test Sunday mornings, at the YMCA pool, pretty much
Or-
every week. It has been a challenge this year, because a lot of members are not available Sunday mornings, and that's one of the challenges we've had to overcome.
The water,
So yeah, Linn-Benton Community College doesn't have their own pool.
We don't have
We
our
get
own pool.
1
We have-
hour
We have 1 hour a
on
week
Sundays
to
at the
test.
YMCA.
So it's kind of, as many people as are available get together.
did you make your own props?
Yes. Fernando made all our own props. Thank you,
Fernando.
Fernando.
Fernando, that 1 hour, go back and do it again.
So how does it work?
We have had issues even just this week that we've had to overcome, but right now it is working really well. It is really impressive what we've overcome even just this week.
Even just this morning.
Just this morning,
Yeah.
in the last like 48 hours, holy cow.
Just burning temper day.
And when we left Oregon, we were not sure how we were going to do here. And we've overcome software issues, we've overcome pneumatic issues, we had a solenoid fail on us last night, we cleaned it, it's works now. That's amazing and impressive, we did not plan for that, the solenoids have not failed us ever. But they are also like 5 years old, so that is why.
There are plans to like
There are plans to replace those, but now that we know that that's an issue,
So this is just pressure side, and you vent the low pressure side?
We vent the air on the surface
yeah.
to run.
But once you push the air to open this, to close this,
Yeah.
then you
And
let go.
it's the opposite side.
There's
one
that
We
goes
have
in
a,
and
there's a
then
system of
something
4
will
solenoids
back out.
that are actuated by like a two-way switch that.
So you do this.
Yeah.
Well, solenoid at the top,
Solenoid at the
solenoid
top, and then the air is supposed to run all the way to the tether. It actuates both at the same time.
Oh, it activates both at the same time. Ah.
Increases voltage at the tether,
And complexity in general.
complexity.
So why the camera orientation? Seems like
I
it's-
think they actually got
Like that.
They're usually like,
One looks like a claw,
one looks
forward.
here, one looks forward.
They kind of overlap a little bit.
That makes a lot more sense.
So where do you source your cameras?
They are drone FPV cameras,
Well, you said analog,
analog cameras.
so they're NTSC.
I think it has to do with the way the information is transmitted. We have a DVR box surface side where we use an Ethernet cable to move the data, but once it gets topside, it goes through balance first to help noise reduction, and then
So it's an NTSC. That's it. Very few people even know about it. It's what used to happen before digital TVs.
Yeah.
And the Balins are, we still use them in our Pro 4.
we have one modification to make to those. We still have noise because of the way that we ran our Ethernet. We have one ground and then 4 data signals and
Yeah.
well,
They
sorry,
were-
but that's not
They're designed for microcoax or something, but
if we run
it's
ground.
They work well enough for our purposes.
It's surprisingly clear, all things
Custom,
considered.
yeah, custom
Yeah.
waterproof housings around those.
Is
They're
it
very
possible?
small.
Yeah.
It's really classified.
15 years ago, we published instructions on how to do that before digital cameras were available. They're cheap and reliable.
Yeah.
Yeah.
How did you iterate your proxy designs?
Or is this iteration one?
These are-
The prop design, like, and the propellers, okay, I see.
This is like third or fourth iteration. It
Of
started,
the thruster mounts,
Yeah.
the robotic thrusters and the propellers on them, right?
yeah,
Okay.
so there's the blue robotic specials in the middle, and then these started a
I mean,
while
we
ago.
did consider making total railroad propellers, but no one took on that project as it. I mean, that's a much.
We don't really need
larger
the
project.
enclosure around it. The enclosure defeats most
It actually would
purposes.
work fine in the pool, but they're
It was meant to be a project just for exploration.
Yeah.
They're Michigan
phones.
is susceptible to grit.
So, no flu?
We do have a flow, it's just not here with us at this presentation.
Okay.
It is really cold.
Why is it here?
It was pulled apart.
I know,
It's pulled apart.
That is what they.
But very briefly, it's okay now, it's working now.
So when's your first run?
Our first run was yesterday at 2:30 on next Wednesday.
How'd you do?
105.
Wow.
We're pretty proud of that, we did not expect that.
Good job.
We're expecting to do even better today. We've learned a lot from the first run. Says the pilot.
So, how'd you lose your software?
Okay, so you see this wooden housing in here?
Yeah.
That used to be made out of 3D printed plastic. And there was a design flaw in it that allowed a wire to get wrapped around the SD card and the Raspberry Pi. So when we were installing it in there, the wire pushed on the SD card and snapped it. And we had it back to the code up recently. So we had to rush and get it working again.
It's always easier to write the second time around.
It took like a month the first time and a day the second time.
Did it come out better?
I would say it's about
Like I said, we had software issues to overcome this week, so.
Yeah.
I have a functional meeting, and every week I randomly ask a person, have you checked your work in today? Because you would be shocked and appalled how infrequently people do it sometimes.
On every other device, I back up my code regularly. It's really hard on that thing.
So how are you pushing your software back and forth? Are you compiling it on the Pi?
Well, it's changed. In early development, we had the Pi external, and we were directly plugging in an HDMI cable and developing on it.
Yeah.
And now for minor modifications, we are just using SSH to get into like a virtual terminal and using a console-based text editor to edit it in there, and then bringing it back from there to our version control system.
It's easier because all the code is written in Python.
Yeah. When you say you're bringing it back, do you just push it from there because it's connected? Like if you get to the repository?
We're actually having some issues with the Wi-Fi chip on it, so we just copy and paste it.
Brutal. She looks a lot better than last year.
We're pretty proud of her.
So next year you want to do props? Is that the goal?
Kind of.
We have a lot of
we have the
Motors
housing.
entirely.
Yeah, we have them all set up with the casing already because we've actually taken apart the robotic ones so that we can like they're ready
We're getting ready to make our
Yeah,
own.
they make thousands of them, and they're pretty good thruster, certainly for the price.
Yeah.
Which is why we use them for.
But there's a couple, the Chinese team and the Boston team found other sources that are cheaper and more effective. Just might want to talk to them about how they source their thrusters. Chinese team, really pretty thrusters.
That's awesome.
What do you know, the Chinese? I'm pretty sure they should help you
Yeah.
in spirit of the thing. Cool.
Yeah.
I think I've got my answer to you.
So I am curious with your stream really even picking, like how do you carry it?
It's so much lighter than last year's model, that one person can just pick it up.
How much does she weigh?
She's
like
like
10
pounds.
Is she, how's her buoyancy?
Good. Now, so the majority of the buoyancy comes from the subsea foam, which is underneath right here,
Okay.
and then we have
Well, a lot of it also comes from
From
the housing.
the
Uh-huh.
Yeah.
housing.
It is very unusual to put your float on the wrong.
It is,
It
but
is.
it actually hasn't caused a ton of
Your
issues.
your stability is okay.
Yeah.
We were actually pleasantly surprised by that.
We were surprised by it because that was a concern we really had.
So if you need to change it, do you just throw weights on somewhere or?
Yeah, we can attach right, like when we were testing it, in Oregon, we had clamps on one side of it just to kind of balance it out, just add weight on one side of it. But we're
worked it out pretty well here.
Mostly,
point.
if absolutely needed, we just add or remove some of the foam on the sides.
Yeah, so
Yeah.
this side has a little less foam than this side, just to balance out what's happening.
Is that American thermoplastic?
Where, sorry, where?
The foam.
It's the subsea foam from Blue Robotics.
Oh, okay, well, they get it from American
Oh.
thermoplastic.
So yes.
Yeah. So I think it was you that said you empirically solved your PIDs.
Oh, PIDs are broken. It's basically a little handmade neural network.
Okay.
So yeah, we
Sounds
want
more complicated than
it is much. It's a little more complicated. So basically, we're getting from the controller a desired like yaw, pitch, forward, lateral stuff, and we want to convert that to thruster speeds. So what we did is we started with just a matrix to just do a weighted sum, and we guessed essentially at how much each thruster contributed to each axis, and then we tested it and adjusted it. And after that, there were still some problems with going forward and reverse because the motors aren't quite perfectly symmetrical. So we added some more layers with some activation functions that change depending on whether they're going forward or backwards. So there's another scaling layer in there. So it's basically a really tiny 3-layer neural network, and it works pretty well.
So you said you had a gyro in it and an accelerometer?
Yes.
What's the hardware source for that?
A hardware source.
What are they?
I believe it is a combined chip, and the chip is from Adafruit. The chip is an LSM6DSOX.
So they're called MEMS gyros, generally they come from cell phones.
Okay.
Microelectronic, something. Every cell phone has one, so they're cheap.
I'm
For
guessing
the
you're
system I'm using.
running your scaling issues is because like part of your flow is occluded. If you take into account the efficiency of your thrusters, you might solve some
And
of
the
those issues.
asymmetrical aspect is not uncommon. Ours is.
Yeah, we were having some weird things. We were doing some testing, and even giving them the same signals, you could feel that some of them are more powerful. So, I mean,
So you can kind of have like an efficiency rating on them to help
Yeah.
balance it out.
Okay, so we
All right.
need to do our
Yeah.
stuff. Thanks a lot, it's very
Good
nice.
luck in the pool today, and thank you for coming this week. Have fun in Tennessee.
Thank you.